Hello, ladies and gentlemen, and welcome back. We're looking now at question number 2 on our 2015 Galois paper. On Wednesday, students at 6 different schools were asked whether or not they received a ride to school that day. Okay, a nice little survey about some schools. A part, so we got 2 light bulbs here and 2 written solution parts. A parts. At School A, there were 330 students who received a ride and 420 who did not. What percentage of the students at School A received a ride? So we know how many students received a ride, and we're just going to measure that out of the total. So we know how many students there are in total because we know who got a ride, who didn't. So we'll figure out the total, we'll turn that into a fraction, and we multiply that fraction by 100%, and that's how we can calculate the percent in this case. Okay, so what do we do? So the total number of students is 330 plus 420, those who got a ride versus those who didn't. That's 750 students. And then the percent that we want is you make the fraction. The number who got a ride was 330 out of 720, and you multiply by 100%. So before I finish that off, I'm just going to double check our calculation. 330, 420, that does add up to 750, and then, oops, it's a 750 down here. Okay, what can we do? Well, I can divide by 50, top and bottom, so I can say 330 times 2%, and then down here it should be 15, because 15 times 5 is 730, and the top is 10 times 3 times 11 times 2% all over 15. So out of 30, we'll get 2 times 11 times 2. So 44. Of course, we could just grab our calculator and work this out. 330 multiplied by 100 divided by 750, and I get 44. But as I've mentioned in the past, I like using my brain rather than my calculator. So 44 is our answer, so 44%. And it's a light bulb, so that's all we need to do. We just need to put that answer there in the box provided. B part. School B has 240 students, of whom 30% received a ride. How many more of the students in School B need to receive a ride so that 50% of the students in School B got a ride? Okay, so let's give a name to the quantity they want. Let, I don't know, R for ride. Now, are we adding students to the school, or... So, there's a certain number we need. So 50% of the students getting a ride. Oh, I guess we don't need to. I was thinking students got added to the school. That's my mistake. So the value that we're trying to calculate is, so we want 50% of 240 to get a ride. We know 30% already do get a ride. So we can work these out. How do you calculate percents of something? Well, percent is measured out of 100%. So you can turn 50% of into a fraction, 50 out of 100 times 240. We can take out a factor of 240, and actually we can take out the 100% and turn it into 50 minus 30 is 20%. Alright, well, 20% divided by 100%, that's going to be, the percents cancel, we get 240 over 5, and that should be 48. So 48 more students. Need rides. There we go. So that's it for our 2 light bulb questions where we just need the final answer. Now, here we are in C part. School C has 200 students, of whom 45% received a ride. School D has 300 students. When School C and School D are combined, the resulting group has 57.6% of students who received a ride. If X% of the students at School D received a ride, determine X. Okay. So how do we figure out these percents? Well, it's number of students getting a ride divided by number of students total times 100%. So we know, for example, what was it, 45? It was 45%, right? Yeah, so number of school C students who get a ride, 45% of 200. That's 45% out of 100% times 200. That's 90 students. So 90 students at school C get a ride. And that's X percent of, what was it? Was it 300 students? I feel like it was 300 students. Yeah, 300 students. So X percent out of 100% times 300. So that's 3X students. Okay? So total number of students who ride is going to be 90 plus 3X. Total number of students is, you can say 200 plus 300, 500 students. So there's 500 students in total. And then what else are we told? So the other piece of information is 57.6%. Well, let's write it like this. 90 plus 3x, the number of students who ride, is 57.6% of 500. So 57.6 out of 100. So the percents cancel. We get 5 times 57.6. I'll grab my calculator for that. So we get 288. So 90 is 90 plus 3x is 288, minus 90 is 3x is 198. Divide by 3, and it is divisible by 3. We can see x is 66. So almost 2/3 of the students at school D get a ride there. Almost 2/3. Okay, so we got X. That's all we need to do in C, but we did show our work. And now D part here. School E has 200 students, of whom N% received a ride. School F has 250 students, of whom 2N% received a ride. When E and F are combined, between 55% and 60% received a ride. If N is a positive integer, determine all possible values of N. Okay. So we've got sort of a range of values here. I'm expecting a couple different values for N. Maybe there's one N for each percent between 55 and 60. Although they're not being clear. They're saying between 55 and 60. So does that mean it can't be 55% or 60%? Well, we'll find out, won't we? It's almost identical to C in terms of our setup. We're going to figure out the number of students at school E who got a ride, number of school F students who got a ride, add them up. Because we know, so number of E students who got a ride is going to be N% of 200, and so that's just going to be 2N%. It's a written question. We'll show our work. So 2N students. It was 200. It's 200 and 250, right? 200, yeah, and 250. Number of students at school F who ride is 2N% of 250. So it's 2N% out of 100%. 250. And when all is said and done, 2 times 250 is 500. 500 divided by 100 is 5, so just 5N. So we might say, in total, 7N students got a ride. Now, we know the percent of students who got a ride is 7N out of 200 plus 250, the total number of students, times 100%. So that's 7N out of 450 times 100%. I can divide 50 on top and bottom. And we'll get 9 here, 7n times 2%. So 14n over 9. Okay. And then we're told 55%. Well, let's start with it less than or equal. Less than or equal to 60. So multiply by 9, 14n is less than 540. And then 5 times 9 is 45, times 11 is 495. Of course, you don't have to do that in your head, as I've said before. You can just grab a calculator if you want. So we've multiplied by 9 on both sides. We get 14. So what multiples of 14 are in this range? N is an integer. So 14n is a multiple of 14. Who would have thought? So, do they want the values of n, or do they just want how many values? Determine all possible values of n. Fine, fair enough. So 495, just divide that by 14. And I get 35. So 35 times 14 is 490. And then add 14 onto both sides, or not onto both sides, just add 14. You'll get 504. That's a multiple of 14. And so that's the first one that will actually count. And then we can add on 14 again. We'll get 518. And then just keep adding 532. And then 546. But now we are outside of the range. So I'll say here is 495. Somewhere in here is 450. So these are the only values of 14n. And so n is either 36, 37, or 38. I'm just going to double check that last one on the calculator. Yep, 36, 37, or 38. Okay, so those are the possibilities. Incidentally, what would the two n's be? 72, 74, and 76. And if you wanted to, now that we know that these are the n values, we could then double check all our calculations, figure out the exact numbers of students, and things like that. That would be perfectly fine. We don't have to check. So one thing you might be concerned about is, well, what if 37% of the students, you get like sort of a half student or something like that? Remember that the 2n students and 5n students in schools E and F are the ones who got rides. And since n is an integer, 2n and 5n will also be integers. So we don't have to worry about the percents not working out like that. So everything's good. All these n's count, and there's only the 3 of them. Okay, speaking of 3, up next is going to be question number 3. Thank you guys so much for watching. We'll see you for question 3 next time.